Good afternoon, everyone. My name is Sam Schwartz, and I'm Member Engagement and Marketing Manager for the AABC Commissioning Group. I want to thank everyone for joining us for the second installment of ACG's Essential Commissioning webinar series. Every month for the rest of this year, we'll be hosting a new presentation covering different facets of the commissioning process. These webinars are endorsed by CABA, the Continental Automated Buildings Association, and this particular session is sponsored by BES Plus Tech, a building energy sciences company. I'd like to go over a few housekeeping notes before we get started. We encourage you to submit questions at any time using the Q&A button on the bottom part of the player. A few will be selected to answer at the end of the webinar, and the rest will be answered via email afterwards. If you happen to be experiencing technical problems during the webinar, please use the chat function to inform one of the panelists. Finally, in terms of continuing education credit, you will receive an email after the webinar with instructions on how to receive your proof of attendance using ACG's Cx Energy app, and that could be accessed on either your phone or a desktop. Today's webinar is Monitoring-Based Commissioning Changes the Commissioning Business Model with Darren Draper, Greg Spiro, and Philip Johnston. Darren has 16 years of experience in the building services industry. He serves as a commissioning agent on a wide range of facilities, including university buildings, research laboratories, healthcare facilities, and data centers. Greg is a licensed engineer with 26 years of mechanical systems experience. Greg is currently Georgia Tech's Senior Mechanical Engineer for Facilities Design and Construction, where he has served for the past 21 years. Philip has worked as a consulting engineer on energy efficiency projects in the industrial and commercial sector for 8 years. Within the last year, he started working with Georgia Tech to help develop an internal commissioning program and lead efforts on energy efficiency projects. Thank you again, everyone, for joining us. And with that, I'm going to hand it off to Darren to kick us off today.
Good afternoon, everyone. Thanks again for joining us, and thanks again to ACG for putting this together and allowing myself, Greg, and Philip to present to you today. And I really appreciate Greg and Philip taking the time out of their busy schedules with everything going on in the COVID era to present to you on some monitoring-based commissioning topics and how it's impacting the traditional commissioning business model. So with that, quickly, I'll touch on, and Duffy, you can put up some polls for us. We're going to present a couple of polls for the group here to give us a little bit of feedback so we know the audience well. You'll see a couple of those come up for you. Please fill those out as they pop up. And then this next slide here just touches on a little bit more about the continuing education credits, how this presentation is certified with AIA and utilize the AABC Commissioning Group provider number and the course number, and you can get your CEUs as required if you so need it. And then in terms of learning objectives today, we're going to talk about a few things. What are the key differences between commissioning, retro commissioning, or existing building commissioning, and monitoring-based commissioning? How does the monitoring-based commissioning process change the way service is delivered to clients compared to our traditional commissioning and retro commissioning models? How do the expectations from owners and operators change with the availability of monitoring-based commissioning? And how does that compare to their current experience with commissioning and retro commissioning? And then what new skills might be required for commissioning professionals today to begin delivering value by offering the monitoring-based commissioning service in addition to or as opposed to their traditional commissioning model and existing building commissioning? And one of the questions actually touches on that and whether you're a commissioning provider today and already offering monitoring-based commissioning as a service line. And so before we jump into that content, how do those polls look, Duffy? So I wanted to take a quick look to get a feel for how our audience is shaping up. And we may need another minute to get the full results in. So maybe we'll circle back on those at the end and we will jump into the content. Thank you everyone for giving us some feedback there. So let's jump in. So for most of you, new building commissioning is a familiar topic, so I don't want to spend a lot of time on it, but just a reminder of what the process is for those that may be somewhat familiar or not familiar at all. The idea of commissioning of new buildings is primarily around the idea of it being a systematic process led by ideally a third-party independent commissioning provider to ensure that all systems perform per the operational intent of the owner and meeting the design intent. All right, so those two primary factors are really what we're after. So you see some key functions there. As I mentioned, independent and third party is particularly an ACG perspective. We believe that commissioning should be a standalone exercise, direct to owner activity. But some of the benefits include the ideas of energy optimization while considering occupancy comfort, performing design reviews for maintainability, operability in the long term, energy efficiency, conducting construction observation and installation verification as the building is constructed, looking again particularly for ensuring maintainability, long-term operability. One thing that's often associated with commissioning, if nothing else, is the functional performance testing of building systems, and certainly a critical part of the commissioning process. And then one we like to point out is the importance of owner training as buildings have become more complicated and needing to ensure that our operations and maintenance personnel, whether in-house or subbed out by owners, have sufficient training with the systems they'll be operating to maintain them and operate them in the long term. All right, so it's a quality assurance process meant to ensure systems work properly. Well, what is existing building commissioning then? So there are a few categories under the existing building commissioning umbrella. Retro commissioning is probably the most common term used, RCx, that being where we go into a building, an existing building that has never undergone the commissioning process. I'll touch on that just a little bit in a minute to how that compares to monitoring-based commissioning. Recommissioning being the process of commissioning a building that has undergone commissioning in the past at the time of new construction, and that could happen at different iterations. You could do it once a year, once every 5 years. That iteration is dependent on the owner's preference. The ongoing commissioning process being the exercise of commissioning a building on a routine basis. Again, the frequency could be determined based on maybe the nature of the building or the benefit of it. And then what we'll spend a fair amount of time on today, and the purpose of this presentation, is monitoring-based commissioning, which I'll give you a decent definition of in here in just a moment. A couple things to point out here. You see on the right there this this graph from Lawrence Berkeley National Lab from 2009, which is a little dated in terms of the study itself. However, the graphic is still very applicable to today, with the point being that commissioning process for a new building is a snapshot in time. We test those systems. We make sure they're operating on the day or soon after the day of turnover. And then over time, those systems can begin to drift. Performance is not similar to your vehicle. It's not self-sustaining. There are activities that have to occur, maintenance, optimization, things to make sure it still performs. So you see a snapshot there below there on that graph of a conventional retro commissioning or periodic recommissioning approach where we see improved savings. And this chart shows it in terms of energy use, but you could think about it in other metrics as well. We see the chart drop down and again drift over time. And then if you see down with the sawtooths happening, where monitoring-based commissioning, the idea is that we're really pushing for persistent savings as the goal of the effort. And we'll talk about that more today. And then finding ways over time to further improve by just improvements in technology, enhanced efforts around energy code improvements, which drive us to be more efficient with existing buildings. So what are the benefits of existing building commissioning as a whole, which all these the subcategories fall under? Energy use and water use reduction are common themes, but in a lot of cases, energy use reduction is not necessarily the top of mind. Some owners don't have pay a premium for energy. Some, in fact, a lot of our clients are paying relatively low dollars per kWh, whereas the water use reduction might be really important. We often see big factors in going with a retro commissioning or existing building commissioning approach being indoor air quality, work order use reduction, occupant productivity, risk mitigation, just getting a general idea of benchmarking, understanding where their building performs. So there's several key benefits, and the building and the owner may dictate what their preferences are in existing building commissioning. So very quickly in existing building commissioning, what are we doing? And focusing on the two primary categories of planning and investigation phase, which typically might fall into up to 3, maybe 6 month activity, depending on the nature of the project. So there's a review of the existing building documentation. We typically hold some form of kickoff meeting to introduce that process, which is very focused on each building individually. which is a little bit different than new building commissioning. It's very tailored to the project and to the building and the operation of that building. Development of a CFR document, which is a current facilities requirements document. So if you're familiar with what an owner's project requirements document is for a new building, think the same thing for an existing building, getting feedback from the owner on what they want the systems to do for that building, not necessarily what they're capable of. It's an important function of existing building commissioning, is defining that baseline, which is, leads into establishing that operational baseline and benchmarking for energy use, water use, occupant productivity, indoor air quality, work order reduction. There's a function of visual inspections, very similar to what is done in a ASHRAE level 1 walkthrough, for example, where, of course, though we're going to go further in existing building commissioning, we're actually going to conduct testing on building systems. And that could be narrowed to HVAC and controls, or it could be much more broad, where we're talking about commissioning of HVAC, electrical systems, plumbing systems, maybe even renewable energy systems. And then ultimately producing a report that includes a list of action items, recommendations, both facility improvement measures and energy optimization, energy conservation measures that'll bundle up into that report. So that's more of the traditional retro commissioning or existing building commissioning approach. Get through planning and investigation phase, hand over a report, and give that to the owner. And if you're lucky, if they have the funds to implement, we go through implementation and a handoff phase, which I won't spend much time on today. But let me talk about monitoring-based commissioning and fault detection. And I'm going to talk about those two terms a little bit interchangeably, though they are not entirely the same, right? So let me just define those. So monitoring-based commissioning is really the implementation of an ongoing commissioning process, with the focus really being on monitoring and analyzing typically large amounts of data, and often condensing that down to information that we can use to optimize performance of the building. That could be for energy purposes, comfort, maintenance, indoor air quality, indoor environmental quality, take your pick, or a combination of those things. Fault detection and diagnostics is typically referred to in the form of an automated process where there's an actual engine or a software platform that's helping to identify those operational issues, report those through with targeted information, and to aid in the resolving in the root cause of those problems. There's a misspelling there as well, by the way, apologize for that. But so you can see the difference here. That basically means that monitoring-based commissioning is not a given that it requires a automation process. It could simply be a commissioning agent utilizing a building automation system front end, or physically being in the building and using a large amount of data to perform that activity on an ongoing basis. So put those two things together, retro commissioning and monitoring-based commissioning. What does it really mean? So we've got, for retro commissioning, benchmarking, documentation review, data analysis, tab measurements, and performance testing, snapshot in time, whereas monitoring-based commissioning is really geared around some form of remote access, typically large-scale data collection, ongoing analysis over time, that could be weeks, months, years, utilizing often a fault detection strategy, which we'll talk more about, and then persistent savings being and optimization being the goal over time in the front end and in the long term, with the idea of driving performance to a point where we're seeing increased performance over time. So thinking about those in two different ways, I like to think about them visually. So one is taking a picture, retro commissioning is taking a picture. One is monitoring-based commissioning is taking a video. One's two-dimensional, one's three-dimensional, and one's playing chess and one playing checkers. And the reason I like to think about it like that is because obviously retro commissioning, like I said earlier, in that Lawrence Berkeley study shows it pretty well in that chart. Traditional retro commissioning, snapshot in time, do it once. Even in recommissioning, it's still one snapshot in time. It can be very labor intensive. Whereas if leveraged properly, monitoring-based commissioning can be done continuously on an ongoing basis. And then how you leverage that with outside input from consultants like commissioning agents, or done in-house by owners like Georgia Tech, can vary depending on the nature of the clients or the building. So how does that layer, what do those layers look like? So typically when we see a fault detection or a monitoring-based commissioning, it involves a remote access, as I mentioned. And so we've got typically a building automation system that's internal to the building. Perhaps the owner has that connecting out to a network. That might be an internal network. It might be also out to the world writ large, with some firewall in between. And then often what we see is a monitoring-based commissioning or a fault detection tool sitting on top of that. Even if it's just monitoring-based commissioning, if we're a commissioning agent, we will need just to see a new building commissioning project, if we want to monitor it remotely during construction, at the end of construction, or during the warranty period, we need some sort of remote access if we want to see it without being physically in the facility. Monitoring-based commissioning fault detection, very similar. And there's complications to that. Obviously, data security, how the traffic flows in and out are all important aspects, and those vary by client. I won't spend a ton of time on those differences, but as you can guess, large-scale owners tend to have, that have a lot of data or might be more sensitive to it, have more protocols in place for how that might happen, or whether it's allowed at all, and whether that has to happen entirely on an internal network. Okay, so the other thing worth pointing out is that you know, compared to 10 years ago, there really are a lot of options in this field at this point for fault detection and diagnostics and monitoring-based commissioning. We at Epsten Group have not used them all. I've seen presentations on many of them, but we've had some direct experience with a few. And the ones I'm pointing out here mostly actually we have dealt with on the Georgia Tech campus. Point Guard, I'll talk a little bit more about in a case study in a moment, one that we used on a building at Georgia Tech. GEM is a JCI platform. IntraSim is put together by a company called Hepta Systems, and we'll show a case study about a building where that's being leveraged on Georgia Tech's campus, and another system actually being used on Georgia Tech's campus that we have had a little less experience with, but Georgia Tech has a little bit, is Clockworks. So coming at this from that angle, we have not dealt with every fault detection platform, but the general principle is the same. You think about a lot of ways to skin a cat. The idea is you use faults or rules, use those interchangeably to identify deficiencies in operation, customize those rules as needed. Perhaps a lot of them are canned rules, and target those at the building operation using large-scale data collection and analysis. So another point worth really bringing to attention is the delivery models, and something that's important from where I sit as a commissioning provider, and to many of you who also provide commissioning services, is the two different ways that this can happen. So what we have often seen is a direct-to-owner offering where a software vendor that provides a fault detection system may offer a software as a service platform to the owner on scale, or in a building as a pilot, and then scale it. And they basically a layer sitting on top of a building automation system, typically often without the need for an additional hardware layer in building or buildings. The other option in that is the owner may actually create their own fault detection model. And I've seen a couple owners that have told us that they actually have written their own custom rules within their own building automation systems. And in one instance, excuse me, where they actually put in another layer for good measure with an external provider. You can see the point is you could build a monitoring-based commissioning tool with your own systems if you have a system that's sophisticated enough to accept that level of sophistication for rules development. And the platform where a fault detection provider may come in with a software as a service is typically a software as a service arrangement. It could be for a year, it could be for multiple years, could be for months, depends on what that provider and the owner are agreeable to. We have seen instances where hardware is necessary inside the building. That could be for firewall limitations. It could also just be the nature of a legacy building automation system. And the reason that's important is obviously one's physically more intrusive, could be more time intensive to deploy, which also means it's more costly. Putting in a Jace is certainly more expensive than just grabbing data from a building automation system with a software patch on a VPN, right, or on the owner server. And often the owner is in the lead on fault analysis. Perhaps they have some agreement with the software provider in the initial stages, but usually the owner is in the lead. They receive the notification similar to they receive alarms from their building automation system, and it's up to them to take action. But another way that you could look at this is with the commissioning agent or commissioning professional being in the lead, where it's the same logistics as the direct to owner, where hardware may or may not be required, but the CXA might actually take the lead on fault intake and analysis, and then utilize their expertise to funnel, if you will, those findings to a set of prioritized recommendations on a weekly, monthly, quarterly basis, whatever it may be, to the big, think of it as the big ticket items, for example, as a way to kind of filter out the noise. Right? That's one big issue with big data. More data is not necessarily a good thing if you don't know how to analyze it, utilize it, and take action upon it. So with the commissioning agent in the lead, assuming the right expertise is there, they might actually be significant benefit to curating those findings. And this process can be similar to what the new building commissioning process already is, where commissioning agent on a new build is the technical expert, is there to help the owner where they don't have either the technical expertise or often just simply don't have the time to commit to the level of effort the commissioning process can provide for a new construction of a research laboratory or even a traditional education building or a dormitory. So they need a third-party independent provider to oversee construction, make sure things are going well, test the systems, give feedback to the design professional. The similar process could be thought about with this exercise. The only difference being it's an existing building, we're getting data, we're analyzing it. We could do that in real time, could be similar commissioning as a service, if you will, on an ongoing basis for months, years, depending on the nature of your agreement with your client. So having identified kind of what existing building commissioning looks like, what monitoring-based commissioning looks like, I want to show a couple of case studies, and both of these are actually going to be from Georgia Tech. One is for an existing building with one platform and one approach, and one is for a new building with a different platform as well. And Epsten Group is involved in both, and so, and of course, Greg and Philip to an extent were involved in both as well, so they'll have some perspective that they'll add in just a few minutes as well. So the first is the Georgia Tech Clough Undergraduate Learning Commons facility, which is a building constructed, I think, around 2010, 2011, a beautiful facility on campus, right in the heart of campus, 225,000 square feet, where a large chunk of undergraduate classes are housed. And it's really a building that several years ago put a lot of different new systems in to pilot them. There's chilled beams, there's some radiant heating in the building, there's demand control ventilation, there's some laboratory spaces. So there's a lot of things happening. You can see from the photo in the mid right there, green roof system, PV, there's a solar water heating system. So there's a lot of fun stuff happening in a building like this. So it was a great opportunity for us to work on it. And so we actually were scoped to go into this building as a traditional retro commissioning approach, existing building commissioning approach. This building did undergo commissioning during the original construction process, as is typical for Georgia Tech. But in the middle of it, we at Epsten Group started to think that maybe monitoring-based commissioning might be something we're trying. Our Point Guard Abundant Power Company came to us with the idea of possibly layering it on, and so we decided to add it into the existing scope we already had and see how it would fit and how it might supplement and complement really the existing building commissioning process. So we did that. We spent 2 weeks on site of traditional functional performance testing and tab measurements in the typical way of a retro commissioning process might undertake. We then deployed the monitoring-based commissioning tool, which was, we'll talk about some pitfalls of it later, of the whole process of fault detection deployment. It actually went quite smoothly overall on Georgia Tech's campus because they're familiar with fault detection, have done a little bit of it already, which you'll hear about in a minute. But the thing that was interesting is that in the 2 weeks or so of testing, we found a lot of the same things using the MBCx tool from Point Guard, in this case, as we did with the traditional existing building commissioning process over, of course, a more laborious activity. And so it was a really interesting case study where we let the two activities complement each other, where we did some field testing, particularly some tab measurements that turned out to be really important for field level activities in the space level results, and then a monitoring-based commissioning platform to supplement that. So what are the primary findings we found with really a combination of the two, with monitoring-based commissioning kind of validating some of those findings? Simultaneous heating and cooling in warm weather, field level controller comm issues, static pressure reset not being optimized, a very common problem. The CO2 sensors not being accurate, which is not probably surprising to many of you who are familiar with CO2 sensors. Over time, they do tend to drift. They had some lab terminal unit control issues that TAB found that largely require tab measurements to find. And then some secondary findings. We had a lot of NAE. NAE is a Johnston product, but excessive object counts. And part of that's just because this was a pilot building, had a ton of research going on with the systems in this building early on. And so that led to a fair amount of added trend data, long-term, short-term trend data. So a really interesting case study of an existing building where MBCx was actually tacked onto retro commissioning. And then a new building example, this is a great building that's actually relatively recently opened. The Candida building for innovative sustainable design. We were the commissioning agent for that, and the design goes back to starting in 2015 and the building opened in late 2019. It's about a 48,000 square foot program. pursuing full living building challenge certification. For those who aren't familiar, I won't go through the whole explanation of what the living building challenge is. Just know that the general idea of living building challenge is to have the building have no more impact on the planet than a flower. Okay, so you might could gather that this is a pretty rigorous undertaking with 20 imperatives, 7 petals representing 7 petals of a flower, and commissioning. Our part of that was a small part of the overall undertaking, but an important aspect of this is that early in the design, intelligent building systems was built into it, right? It's obviously one of the big takeaways of 2 things really is you have to be net positive energy, 5%, net positive water, which may on the face of it not sound as challenging as net positive energy, but it means we have to produce water basically. So it's complicated, and one of the only ways to really do that is to really know what the building performance is in real time over the course of the performance period of 12 months. So an intelligent building system was really important to integrate all these systems together. So what did we end up doing? In addition to that fully integrated system requirement, this group, myself as the CXA at Epsten Group, the engineer of record, Newcomb and Boyd, and Georgia Tech, Greg and Philip being primary folks, helped develop a custom rules list and limited that to the top 25, with the idea being not to have a bunch of noise, a bunch of nuisance alarms, a term that you probably heard many times. We wanted to focus on the big items that are either significant operationally or significant on energy and water performance. And you see a summary of the rules that are in the system there. This is the HEPTA system intro stem, and Greg will talk a little bit more about this in a minute. And then you can see actually a little snapshot of our working document that we use to prep those rules together during the working sessions late in the project to finalize them. So some hurdles to be aware of. If you're a commissioning provider, these will be important because it is not necessarily the easiest thing to undertake, especially if you haven't done it before. So data noise, glorified alarms is a common problem, meaning if an owner already has a building automation system and they're just inundated with alarms, there's certainly a reasonable expectation they're going to think that this is just more data and more noise, more alarms, nuisance alarms. So you have to clear that hurdle, understand going into it that this system, a fault detection system of any merit, not necessarily going to resolve those problems for them. You have to be cognizant of that. Onboarding can be complicated. It can be different for every owner, and particularly even with a solid owner, even the building by building, depending on the nature of the systems, the legacy of the building automation system. So there's complications to that. There's complications to remote access, firewall requirements, all of that. The timeline to complete the process is not 5 minutes, right? Even if it goes smoothly, it can take a little while. It's not 100% plug and play, which kind of further hints on that. Another one really important is the rule set and fault ownership. Who owns the data? How is that data secured? Who owns the rules? What's the transparency there? What level of ownership does the building owner have to those rules? How do you deal with that problem at the provider level? And then another one that I think is really important from the commissioning perspective is the process champion. Who is in charge? Who's taking the lead? Philip will make a couple of points about this in just a minute on his slides as well. And what data are you getting, and is it actionable? Making sure it's actionable, or it's just more noise, right? The other thing to think about is if you're a commissioning provider, it's a new service, right? Or maybe for some of you, it's an existing service you've been doing for a long time, but for folks like me who haven't been doing it for a terribly long time, it basically means there's an opportunity there. There's also an opportunity to screw things up, perhaps with new owners or existing clients you already have. And the other thing about having attachments to a particular platform, perhaps if you're used to being in the third-party role, you have no attachments to vendors, particular controls vendors, equipment vendors. You're a third-party objective commissioning agent, so being attached to a platform might be cumbersome for you. And then in new construction, not to be overlooked, is the level of integration that's required. And we've seen it's an easier process with existing building commissionings because generally speaking, the data, the systems are already there. And new build, they're being constructed at the same time you're trying to layer on this intelligent building system or fault detection system. So it's not a given that it will go smoothly. Some skills that are really important for a commissioning agent to be thinking about if you're in this business or thinking about getting into it. One thing that I, as a commissioning provider, think about is you have to be open to adapting. The only constant in life is change, and I should remember who that's attributable to, but I don't, but it's still true. Life is changing all the time. That's true in as commissioning agents. Nothing is static. So you have to be prepared for that. And monitoring-based commissioning is here and coming. Fault detection is here and growing. Avoiding death by data. So as I mentioned, clear the noise as you're a commissioning agent. If you can help work with your clients to vet data, to vet faults, prioritize them for them, understanding how to yourself analyze them and curate them. Leveraging your existing building commissioning experience over years, however many years you've been doing it, to perform analysis with a tool that helps supplement that over time. May do a lot of that legwork for you, and think really about the top findings that you've had in existing building commissioning, how you might apply those to a monitoring-based commissioning tool. IT skills. So I personally get cross-eyed when we talk about IT with new and existing buildings, but you need to know enough to be at least dangerous so that you can talk the language of IT staff on the owner's side, so that you can be a player in between a software that you utilize or that a third party utilizes, to know what the ebbs and flows of that are. And then a big thing, and this is true existing new building commissioning as well, is being action oriented. Is only as the monitoring-based commissioning process, fault detection, is only as good as the action that follows the findings. So with that, I'd like to turn it over to Greg Spiro to talk about the next couple slides. So Greg, go ahead when you're ready.
Thanks, Darren. Yeah, so first, just kind of an overview of kind of commissioning at Georgia Tech over the years. We, like so many owners, I think really got into this, when LEED was gaining popularity and commissioning, new buildings, major renovations. So it's been standard operating procedure on campus for quite some time. In 2008, the state passed sort of kind of their version of LEED in a sort of way, and it required commissioning on projects over 10,000 square feet. So that was something that we sort of, used to really kind of expand what we were doing and make it our own. And so using that requirement as baseline, in those projects of 10,000 square feet or more, we've taken on commissioning as more of a sort of enhanced commissioning, where we're emphasizing more scope on the front and the back end. I often, think of our commissioning agents as sort of the glue on the front end and the back end of a project, where on the front end, we're getting them on board earlier, and they're forming that glue between the programming and the design teams. And then on the back end, keeping them on, through that year of occupancy, that warranty period, and sort of forming a glue between the design team and our operations teams. So one of the things that we've done on the front end side is we've recently developed a boilerplate OPR and some boilerplate specifications with the assistance of Epsten. The idea with the OPR is to really develop something that's consistent, that it's meaningful, and really efficient in preparing. It's sort of more of a fill in the blank thing. You're not attending these charrettes on a project by project basis that may not be well attended, or not really getting the right kind of input, and trying to really give this document more meaning. As you go through the design process, it's a living document. So if things change, we want to reflect those in the OPR, and our commissioning agents are playing a role in that throughout. And then on the back end, having the commissioning agent stay on board through the warranty period, so that we're ensuring that our performance goals are being met, that our functionality is sound, and that our general contractors are held to account for any warranty issues that come about in that period. So throughout all of that, we really want our commissioning agents to be engaged with the different technologies that are available on campus, and Philip will speak more to that. I mean, he was brought on roughly a year ago to develop a fault detection program, and so as that matures, it's definitely something that we want to engage our commissioning agents in and sort of create a feedback loop for us in design and construction with our operations team, and so our lessons learned are well adopted and reflected in our standards. In the end, I think all of this really gets to what so many industries are facing today, is the leveraging of big data. And the screenshot I have here to the right is, for me, it's probably my favorite screen that we have in all the different platforms that we have. And this is our Optimum Energy platform that optimizes our plant performance at our 2 district chill water plants. And every one of these little boxes you see on here is really important today. This is one of the 2 plants. You can see the 7 chiller lineup. And any one of these boxes, I can double click very easily, bring up trends. I can overlay trends on different information. And really, after implementing this, has given us just such a window into, you know, how things are functioning, how well they are, how efficient they are. And so I think that's what this gets to, is more than anything. If you can go to the next slide, Darren. So in design and construction, my focus is very project oriented. And so I want to, you know, kind of speak to 3 different projects that we've had within the past few years. And each one of them, we're sort of implementing a different platform, which is some of the struggle in all this. It's like everything, you know, there's a tool for everything, and there's not always one tool for everything. But in 2012, the state of Georgia passed legislation that allowed guaranteed energy savings performance contracting. And we were approached by the Board of Regents with an opportunity about 5 years ago. So with that project, it was the one I spoke to earlier, with the Optimum Energy platform for our 2 district energy plants. Made a lot of sense for us to concentrate on that. In 2 buildings, we could have the effect of 14 million square feet on campus. And it's been a really successful project. We just completed our 3rd year of performance. But performance is huge in validating the measurement and verification process, understanding, you know, how well you're doing, and not just at the end of the performance year, but as you go. And so with all 3 projects I'm going to speak to, that monthly reporting is really key. And on this screen, you'll see some of the measurements that we can see from that Optimum Energy platform that we're evaluating month to month, tracking how well we're doing. In the end, this project was about, again, our chill water distribution, and you know, going from a primary secondary system to a variable primary system, putting in the Optimum Energy platform to optimize, you know, all of our equipment was at the core of this. We've gone from over a kW per ton in production to in the 0.65 to 0.7 range. Huge demand reduction on our campus, savings of excess of $1.5 million a year, and we received a $500,000 check from Georgia Power as part of this for that demand reduction. So that was the OE platform. More recently, we've had another guaranteed energy savings performance contract that's focused on 2 of our lab buildings on campus. It's sort of Georgia Tech's inaugural voyage into a smart lab concept, very much demand control, ventilation, airflow reductions in the lab environment, a huge key to our savings. We've calculated roughly $4.50 per CFM annually as part of that savings. So that project is also being delivered through Guaranteed Energy Savings, and that monthly reporting is super important. And so we're using the GEM platform there. That's our JCI. We have a JCI campus. We have a sole source controls contractor, and because it was so HVAC oriented, it made a lot of sense for us to use the GEM platform for that. And so we built in faults to that, as Darren was pointing out earlier, and both on that and the Candida project, our sort of methodology in doing that was to first sort of think about, you know, what is the behavior we want to flag, and then to write rules, you know, that we thought would best do that. And then the third project I want to speak to is the Candida project. You can go to the next slide, Darren. So, and Darren spoke to this a little bit, super unique project designed to meet all the requirements of the Living Building Challenge. And as Darren mentioned, 2 of those are net positive energy. That is, the building has to produce more energy than it uses without combustion. So there's a large PV array a part of this. And what you see here is through the Optimum Energy, through the Enterson platform, which is using the engine of the SkySpark. And this is a tabulation by month for all of the energy metering in this building. So at the top, you'll see what the building produced by month. This first column is December, going January, February, March. and you can see all the sub-meters. So you can, it's in just sort of one quick glimpse, we can see how we did on a monthly basis, how different meters compare to each other, how the production is ramping, how the usage is ramping. And at the bottom, you can see the percentages of overproduction. So back in December, it was about 119%, then improving to over a 5-to-1 ratio, somewhat as a result of less use in the building because of COVID-19, but over 500% production. So the energy in this building is really impressive in terms of what we've been able to achieve, and this has played a really key role in tracking that and ensuring that we're meeting in this case the energy imperative for the Living Building Challenge. In this case, because there were so many systems, there's the water systems, there's the lighting systems, there's the PV systems, all of these different systems that go into this building, and integrating them was so important. And so that GEMS platform really wasn't appropriate. In this case, we've gone with this Centrosyn platform. And with that, I'll turn it over to Phil.
Okay, thanks, Greg. So while Greg is in the design and construction department of our facilities group, I'm more in the operations and maintenance side. And so what I've been concerned with is mainly our other buildings that haven't gotten any major renovations or projects recently. How are we addressing the issues in those buildings? And basically what I've been working on is building an internal commissioning fault detection effort to address these buildings. We're in the real early stages of that. So, both Darren and Greg have talked about, multiple platforms that we have on campus and how we utilize those. We ran into a lot of pros and cons of each one, and what platform works for you is going to be very unique to your needs and wants and what that platform does. But what I would say is, regardless of what platform you use, it's very important that you have a mix of what I call, white collar and blue collar roles, because, and Darren kind of hinted at this, but if you have someone that's highlighting a lot of issues, but then there's not engagement with the personnel that can actually go out and fix these issues, then you're not going to have real results and anything to really claim as a positive, outlook for this stuff. So it's really important to, when you're forming a team to, address these issues, that you have a full team of people that can work and really fix the issues that you're running into. And as you can see, well, go back one second. The pictures here, the snapshots here are of the Johnston controls platform that we use. And so, each little line there is like a fault that we're maybe taking a look at. Okay, you can go to the next slide. So I guess in general, we're evaluating the rules that we're putting together. That's a really important part as well. The famous saying, garbage in, garbage out. So you really want to make sure that the rules you write are significant, and they're really going to drive energy and maintenance savings. And, what we're really trying to, our ultimate goal is transforming our program into a reactive program into a predictive. And, that's a very long-term goal. It's not something we're going to achieve tomorrow, but that's what we're kind of driving towards. And, I think we all know that's going to be very beneficial, because most maintenance departments are very short-staffed, they're low on resources, and because of that, our buildings and systems suffer. And so becoming more predictive and fixing those issues before they really become significant will help everyone in the long run. So yeah, there's also indoor air quality issues that recently have become very, very important. And these monitoring type programs can help with that because you know, they have CO2 sensors. There's stuff that's even more important than CO2 now, and measuring occupancy and really addressing, you know, air quality while people are in that space. And what you see here are more snapshots from the IntraSim platform. Again, these are just like every line item is like a fault or a specific issue that's generated from the set of rules that we developed. And I think that's all I got. So I'll pass it back over to Darren.
Thanks, Greg and Philip. Really appreciate it. And so with that, that really puts a bow on it. I'll, at this point, we've got about 13 minutes left. We'll open it up for questions. Sam, if you want to take it away.
Okay, great. We have about 8 or so questions lined up, so let's get started. The first one is, we are typically in the commissioning authority in the lead model and find the largest monitor-based commissioning success blocker with SAS, regardless of level of owner motivation, are challenges with obtaining facility building management system trend reports or trend data due to uncollaborate control contractors or control vendors that simply will not set up trend reporting. Do you find the same challenge, and how do you typically overcome it?
Okay, that's a good question from Eric there. Yeah, well, so from what we've experienced thus far, you know, certainly what we've found on Georgia Tech's campus is that doesn't exist. And that might be because they do have a sole source arrangement with Johnston Controls, and they have plenty of incentive to stay in that position. So they're pretty cooperative when it comes to even if it's not their platform that's being used, they tend to be cooperative. Not to mention Georgia Tech has, and Greg, if he wants to speak to this further, can, but basically have mandatory requirements with setup of trend data and alarms. That's part of their design and construction standards. So every new build gets, or every retrofit project gets standardized alarms and trends by default. And that data is generally going to repository no matter what. So the data is usually there. In a couple of other instances, we have seen that be a bit of a hurdle, but I wouldn't put it any higher than the same hurdle that exists in new building commissioning. It is something you have to overcome, and that's easier in some instances than others. Sometimes it's more about the individual with those vendors than it is about the vendor, the controls vendor themselves. But it is a hurdle. It's a good one to point out, and I would simply add it to that list of hurdles you have to either overcome or be aware of before you get into this practice of commissioning in the lead.
Yeah, I would add to just a couple points. One is it's super important, and I can understand where different owners may be more difficult to work with in that regard. I think there's 2 things you can do. One is you get it in the specs. You know, where you can do that, make it a project requirement that this is something you're going to do. The second thing I think for all the commissioning agents is to be as proactive in it as you can. Just know the systems, know how to do it yourself, and that's one of the things that, you know, really, you know, we're building relationships with the commissioning agents that we have so that they are leveraging our technology, so that it's not just Georgia Tech employees, you know, that they are an extension of our staff in that regard. Now, and I understand maybe not every owner may take that outlook, but so I think being as proactive as you can, knowing the systems, knowing, you know, hey, give me the access and I'll do it myself. That's welcome.
So the next question we have lined up: how does monitoring-based commissioning process blend in with the owner's building maintenance process?
This is a great question. I mean, the only thing I'll say, and I think Philip may want to address this sitting on the operations and maintenance side, working on this at Georgia Tech, is I think for it to work well, if it's going to be utilized, is it has to be prioritized and actionable information for O&M staff, so that it is not just noise. You have to clear the noise. And sitting where I sit, that's one of the biggest things, because I think it's actually a turnoff to O&M folks if you just send them. I mean, you look back at those snapshots we were showing you, Philip was pointing out from GEM and from Point Guard and from IntraSim. If you're an O&M person, you've been looking at controls alarms for 15 years, that doesn't look all that different to you, what you just showed them. So you have to make it clear to them how it's going to improve what they do and not make it just more burden. Philip, you want to add anything to that?
Yeah, I think one benefit to FTD is it's really trying to find the root cause of an issue so that you're not going on a treasure hunt, but you actually, know what's wrong before you even get to the site. And I think, if maintenance has an understanding of that, that's where the real value is, and they can get on board with that. They also, have a huge PM workload. And so kind of the early sales pitch of this is that the inevitable goal is to reduce that PM load and solve these problems before they happen.
Yeah, I would just add, I think, Philip spoke to this. I think one of the things that he's done with the team he's developing is partnering with, a Georgia Tech employee who has been on campus for a long time on the O&M side. It's that partnering of that white collar and blue collar. And I really hope that creates more O&M buy-in too.
Okay, have any of the speakers on the panel worked with a performance-based contract or project where monitoring-based commissioning processes need to prove energy savings?
Yeah,
I
spoke to that in the presentation, but yeah, we've, at Georgia Tech, we have 2 guaranteed energy savings performance contracts. I'll say that in both cases, there's a commissioning agent who has been on the project, but they have not necessarily been charged with the monitoring of the project past construction though. But the tools are there, and it could be done by them. We've been more independent about that, I guess, for those projects because of the uniqueness of them. But I don't see why that couldn't be the case.
Yeah, and I'll just add one thing to that. I'm speaking to another, basically an MBCx provider recently, who said that they basically do this turnkey. They do the retrofit, they'll do the MBCx tool process, all in one package. So they think of them actually, I almost think of them as the energy service provider, though it may not be a guaranteed energy savings project. So that's another approach to it, a unique one to some of us who have been in the third party role a long time, but certainly an interesting approach on it. And I would add that I don't see why a monitoring based commissioning process couldn't be very valuable to an energy savings project, whether it's done by the commissioning agent for objectivity or by the guarantor.
Actually, in both cases, it is for us, has been done by the guarantor. The energy service provider is technically responsible for the M&V. Right. So, they're doing a lot of the reporting, they're gathering a lot of the information, but I think it's really important for us as an owner to understand how that's being done, where the information's coming from, and double checking it. So, we're doing that as well. In the case of the second project that we're doing, as part of that M&V, we actually have and so we're claiming operations and maintenance savings through this, but we actually have an employee from the energy service provider who is now going to be part of our operations and maintenance staff. And so part of their charge is PMs and monitoring, essentially monitoring based commissioning. I mean, they are using the GEMS product to follow these faults and check on systems as a result of that. So, I mean, this is a person who's not technically part of the commissioning team that was on the project, but that's what they're doing.
Okay, I have another question for you guys. How would you describe the difference between continuous commissioning and monitor-based commissioning?
Oh, so that's a good question. Well, continuous commissioning, first of all, is trademarked, so I can't use it. I can't say where you have to fall under that category of being an official offerer. But the point is, the way I think about it is, it's all under the umbrella of existing building commissioning, generally speaking, where you are on an ongoing basis commissioning a building or building systems or a set of systems within a building. It could be very narrowly focused. It could be one air handling unit in VAVs if the retrofit applies. But the idea is the same. The frequency of how it's applied for ongoing versus monitoring could be different. But in general, I would suggest that the monitoring-based commissioning approach, it implies that you're doing data analysis without necessarily being in the field, at least as much as you might be with a traditional ongoing commissioning process. So plenty of healthcare facilities undergo ongoing commissioning regularly or continuously, right? All the time. And that might be a pretty laborious effort, a lot of tab measurements, a lot of calibration. Monitoring-based commissioning, it's not a given that that has to happen, at least at the same level of rigor. You do have to trust the data and have to validate the data. Calibration and tab measurements are important. But you're largely leveraging the tools, either the building automation system or a combination thereof, and or a fault detection system to supplement the expertise of a commissioning agent. And there are numerous benefits to that. I won't go all the way down the list, but one of the obvious ones is probably that it costs less money to the owner. And so, from where I sit as a commissioning provider, if I can do more projects, more existing buildings for a client or more square footage, remembering that most of these funds for existing building commissioning come out of the O&M budget, which is not, as Philip touched on, is a thin budget often for almost every O&M team, then that's all the better from a commissioning perspective. More area affected means more problem solved, really.
Another question we got lined up: who should be on the team to select the software vendor? Energy manager, facility manager, who else?
Well, I mean, from where I sit, it may not have been obvious, but it's not a given at all that the commissioning agent has to even be there. There's the fault detection direct to owner is a common approach. And so I'll let Greg and or Philip speak to who on the owner's end might be asked. It's certainly, if you're a commissioning provider who's dealt with them and you're asked for input, I wouldn't hesitate to offer opinion on it.
Yeah, I'll be honest, we probably wouldn't include the commissioning agent in that decision process. I mean, it's going to be, it's a combination of our engineering staff in design and construction and in operations and maintenance, and then also, obviously the technicians who, are going to be more hands-on. They're a critical voice in those kind of decisions.
Yeah, the important comment I'd like to make is you should involve everyone that's going to engage with that platform after the fact, because if one manager or just a few people pick the software without getting that input, the execution might not go as well, because certain people didn't get engaged in the beginning, and they're just going to disengage if it's a platform they don't really see as useful.
We have time for just one more question. Someone's asking, do you have a sample monitoring-based commissioning specification?
Oh, wow. No. Well, what we have typically seen and utilized for new builds, if we're talking about a spec book, is an intelligent building systems, or you might call it a fault detection system. It's typically a Division 25 specification that stipulates what the integrator must do. And there's, you get into, often you'll see drawings required for that, for networking and whatnot, meters to be pulled in. That's typically the way we've seen it done. If we're speaking more about an MBCx monitoring-based commissioning plan, yes, there are some samples that are out there. In fact, I think the Department of Energy has one or two that might be worth looking at. What I tell people about existing building commissioning plans or retro commissioning plans is they should be tailored pretty specifically to the building and or buildings that are being undertaken. It's just almost every building is unique. There are very few, even if Georgia Tech's a great example, they've got one controls vendor, but just a number of ages and varieties of controller types on campus that vary in age. And so obviously the level of effort required to undertake monitoring-based commissioning depends really on the building and the controllers in the building. So it has to be pretty tailored down to the specifics.
Okay, I'm afraid I do have to call it for the end of the Q&A session. Philip, Greg, Darren, thank you so much for being here. I want to close things out by thanking everyone who joined us, including all of our members across all three affiliated organizations. We're glad to have this opportunity to continue to virtually connect. Everyone participating should keep an eye out for an email with information regarding your learning units from ACG's Cx Energy app. And while in that app, I'm also asking everyone to please take a moment to evaluate this presentation. We'll be continuing our webinar series next month, October 8th, 2 p.m. with Indoor Air Quality in the COVID Era, Commissioning and Construction Considerations. Please be sure to mark your calendars for Cx Energy 2021 in Dallas, Fort Worth. And the call for abstracts is open, so please take note of that. Have a wonderful day and stay healthy, everyone.